Okay, here are the conjectures for lesson 5.5, the properties of special parallelograms. The first one is the double-edged straight-edge conjecture. It states if two parallel lines are intersected by a second pair of parallel lines that are the same distance apart as the first pair, then the parallelogram formed is a rhombus. And so just to show this is a rhombus, what we can do is select all four of the sides and measure their lengths. And you can see that no matter how this moves, it will always stay a rhombus. Conjecture number 46. Conjecture number 46 is the rhombus diagonals conjecture. It states the diagonals of a rhombus are perpendicular and bisect each other. So we got to show a couple things here. The first is we want to show that they intersect at 90 degrees. So if I show this marker tool here, I can click on the intersection of the diagonals and drag into the angle and show that those are indeed perpendicular. I also want to show that the diagonals are bisected. And so what we're going to have to do is we're going to show or select the distance from C to the intersection, and we can measure that length or measure that distance. And let's change that. Let's see if I can. It's going to give me a hard time, I think. Let's change this one then. So if I double click on the A, let me change this to point E. Okay, so we can see that the length from C to A is 3.7, and then we can measure the distance from E to A. Measure the distance. So those lengths are equal. And then the distance from B to A, measure the distance. And that's going to be the same as the distance from D to A, measure the distance. So you can see that no matter how the rhombus is moved, that the diagonals are always bisected and that they always intersect at 90 degrees. In fact, with the marker tool, if you want to mark that this side or this segment is congruent to this segment, and then this segment is congruent to this segment. And how you can add a tick mark is you just click it one more time and it will add a third one. Let's see if I can add it here as well. Okay. Conjecture number 47, the rhombus angles conjecture. This states that the diagonals of a rhombus bisect the angles of a rhombus. And for this one, it was technical enough that I think it's just easy enough to see that the angles are all bisected. So what you can do is just go ahead and play around with these two endpoints here, or these two vertices, and show that no matter how the rhombus moves, that their angles are always bisected by the diagonals. Conjecture number 48, the rectangle diagonals conjecture. The diagonals of a rectangle are congruent and they bisect each other. So if you select the two diagonals and we measure their lengths, you can see that the lengths are congruent. And then we also want to show that the diagonals also bisect each other. So we're going to show the distance from A to the intersection, and if I measure that distance, and let's again do the same thing. Let's double click on A and change that to E. Okay, so the distance from E to A is congruent to the distance from C to A. So just C to A is highlighted, measure the distance. And then I'm also going to show that the distance from B to A is congruent to the distance from D to A. Okay. Again, no matter how this moves, you're going to see that the diagonals are always going to be congruent. There's no way to make them not congruent. Again, if you want to mark that with your marker tool, we can show that this segment is equal to that segment, and this segment is equal to that one.